Hello. What I'm going to try to do today, and today's actually leap day. It's February 29th, 2012, and it's the one day we get every 4 years. Adds into one day, and it actually has totally messed me up because yesterday, which was actually Tuesday, I thought today was Thursday, and somehow we got this Wednesday in the middle. But neither here nor there. This is the SFA Star Chart, which in my opinion is one of the coolest astronomical charts that are out there. And what it's basically done is it's taken a three-dimensional sphere, known as the celestial sphere. Sort of have to kind of imagine the Earth as being maybe like, let me get a smaller, imagine the Earth as being sort of right there in the center. Our axis of rotation is normally tilted 23.5 degrees, but this is actually going to be showing it straight up and down. We have the north celestial pole up here. We have the south celestial pole down there. And we have the celestial equator going here. So we have the north celestial hemisphere, the south celestial hemisphere, and it has a primarily westerly direction. If you're sort of in the inside, we rotate east to west, which puts us this direction. So what we do is we actually see the celestial sphere move this way. It's actually broken down into a two-dimensional chart with three different charts. One showing you the celestial North Pole region, which actually starts at 90 degrees, which is the North Celestial Pole, and I think it reaches down 60 degrees. Yeah, so it reaches down to 30 degrees. So basically what it does, it goes from that North Celestial Pole up there down about 2/3 of the northern hemisphere and shows you everything that's above that line. And then the South Celestial region, pole region, actually starts at the South Celestial Pole and goes up to about that line, 2/3 of the South Celestial Hemisphere. And then we get to charts 2 and 3, which is the equatorial ecliptic region, and that actually reaches up 60 degrees and shows you basically this much. And then it's broken down into two, showing you like this side right here, going this way, all the way to the far side. And then this other side, chart 3, will show you the other side. So let me actually show you what the chart looks like. This is that North Pole region, and it's actually set up as showing you Polaris. And if you notice, Polaris isn't quite at the North Celestial Pole, but it's pretty darn close. If I show you a video later on, not particularly in this video, but I will make a video using a program called Stellarium, and this actually is a really cool program of showing the celestial sphere, and it actually can go in real time, which is really slow, or you can actually speed it up or slow it down, go backward, you can go forward, you can pick a date, I think 3,000 years into the future. You can also go back 3,000 years in the past and see how some of these stars are actually moving. And we tend to think of these things all being in this celestial sphere as being very stagnant, but each one of these stars is moving in different directions. This one could be moving toward the middle, this one could be moving outside, this one could be moving inside, this one could be moving up, this one could be moving down. And this is just how Auriga shows up right now with its alpha star, alpha meaning the brightest apparent brightness star, not really showing you whether the star is big or close. It's a sort of a accumulation of the two. But that is its alpha star, and there's the beta star, which is the second. It's a Greek alphabet. Each one of these things has a symbol. I'm not talking about that today. But this is that North Celestial region. It does go between 90 down to 30 degrees, so it's showing you 2/3 of from the top. This would be like if you were Santa Claus standing at the North Pole looking straight up at your zenith. This thing would be over your head, and it goes down basically 2/3 of the way towards the equator. Okay, that's called declination. Declination is the equivalent of latitude. We do also have something called right ascension, which starts up here. This is the vernal equinox, and it actually goes in a clockwise direction to 1 hour, to 2 hours, to 3 hours, because the Earth actually seems to spin the other way. And I'll show that to you fairly soon. But if you take a look at it, what you can see is lots of stars. The stars do have lines on there showing you patterns, like this is Andromeda, Zeus's daughter. Really close to that is Perseus, the one who actually saves Andromeda from Medusa, riding Pegasus, which is just off the screen here, going out to some island in some fictitious ocean and chopping off this horrible looking female with snake hair that you can read about Greek mythology later on. Constellations do have mostly animals and people, but there are things like this triangulum, a triangle that is used in architecture and/or math. There are people sitting in chariots. There are bears, big bears, little bear. Polaris is actually the tail star in Ursa Minor. There are dragons. There's an Ethiopian king, Ethiopian queen. There's a big swan heading towards the south, away from the North Celestial Sphere. Hercules, Bootes. There are lots of things that are up here. But latitude, same thing as declination. You go from the equator up to the North Pole, 90 degrees as high as you can get. Longitude, it's called right ascension, so it's actually moving to the right, moving in this direction because the Earth actually spins the opposite way. So things are going to look like they progress this way, east to west. Okay, I do call this the SF Chart Plus. Let me scroll up a little bit. The Crazy 88. Now, why do I call it the Crazy 88? Well, because there are 88 understood constellations, worldwide understood constellations, that break this up like this is Lyra, and you can sort of imagine like this part of the sky is actually being in Lyra, and if there is a celestial object or a celestial happening in this area, they will say it's in Lyra. It's almost like saying the state. If I show you this, this is actually that Stellarium, and you can see that I actually have the constellations turned on. I can actually spin this thing, but it shows you Rigel and Betelgeuse. I'll talk about it. There's the actual belt of Orion. He has a saber off his belt. A lot of times he has a shield because he's got Taurus, the bull, actually running toward him. And you can see right now the moon is in Taurus. I'm sure if you're into astrology, that's got to mean something to somebody. He is the god of good hunting. He's surrounded by a unicorn, a little dog, a big dog, a bunny. There are the Gemini twins up there. He's got lots of things around him. But going back to this, this is 44 of the Crazy 88, and if I scroll down really quickly, going through the equatorial views, there are the other 44 of the Crazy 88, and they are in alphabetical order. Most of these you can see from the Northern Hemisphere. Like I said, I'm outside of DC. You can see these. Some of these you can't. Some of these you get to see all the time. They're called circumpolar constellations. And most of the constellations you see probably above this 50-degree mark, you get to see these things all the time, every single night of the year. They circle the pole. They're called circumpolar constellations. Strange as it may seem, going back down to this one, the ones from about 50 south, you don't get to see these at all. And these are also called circumpolar constellations. They never rise above the horizon. The ones that in the northern hemisphere, that north polar view, these guys never set. That's why they're called circumpolar constellations. Okay, if we go down to the actual equatorial view, this one tends to have more sense. Let me give you a little bit of a lesson on where you are. This is the celestial equator. If you stood on the equator with a big laser and burned a line across the celestial sphere, this is the line you would create. This is called the ecliptic, and if you take a look, you can see the months and the dates. This is increments of the sun. As we are orbiting the sun, moving in a counterclockwise direction, which is sort of like left to right, we actually get to see the sun move a little bit, 1 degree, just about 360 degrees and 365 1/4 days, just about 1 degree a day. And the sun actually does seem to move through Pisces. It seems to move close to Aries, moves through Taurus, Gemini, Cancer, Leo the Lion, but those are the signs of the zodiac, because the sun, which was important even to the ancient people, because the sun tended to spend some of its time in those particular constellations. One constellation that's pretty easy to see, Orion, like I said before. There's Betelgeuse, the Alpha Star. There's Rigel, the Beta Star. This is a beautiful blue-silver star, even naked eye, 900 light years away. The light has been traveling through space for 900 years at the speed of light, 186,000 miles per second. And if you actually go outside and see it, which is a beautiful constellation, even today, the 29th of February, if you go out and see it, that light has been traveling through space for 900 years. This is Betelgeuse, or Betelgeuse. It is 520 light years away. When you look at Betelgeuse, just like Aldebaran up here, these two stars have a reddish tint. These are red giants, where Rigel is a blue giant. But because this is the Alpha Star at 520 light years away, this is the Beta Star at 900 light years away, this is a very massive star, probably one of the two that you can see with your naked eye, big stars. Now this is Sirius, and Canis Major, the big dog, that's the actual brightest star in our sky other than the sun. So I'm not exactly sure how far that one is away, but that is the brightest star in our sky. So this is probably a bigger star, but it's 520 light years away. This is a closer star, so it looks bigger probably because it's closer. Gemini, two twins, one named Pollux, one named Castor. They are actually on the ecliptic. If you take a look at the times down here, starts at 0. This is called the vernal equinox, somewhere around the 23rd of March. This is when the sun actually moves from its southernmost point and crosses the equator heading north. And then if you follow it up, you go over there, it's right around June 21st, my anniversary, where the sun is highest in the northern sky. This is why our temperature is warmer. It's higher in the sky, it spends more time on our sky, more direct solar radiation. And then it goes back down for July, goes into August, and if I scroll over this way, you can see it's in, there's Leo the Lion with Regulus, the regal star. And then it goes back down, crosses the celestial equator again. This is the autumnal equinox, and then it heads south, giving you the mirror image, the exact opposite of this, highest for the summer solstice. And then if you take a look, any of these stars can actually be located by how far they are above or below the celestial equator, and how far they are from that 0 degree. So they're all given a certain degree going up, and they're given a certain hour, and each one of these little lines that you see here are 5 minutes of right ascension. So there should actually be quite a few of them in there, but you can actually do that. So if you wanted to find Rigel, all you have to do is take a look and see that it's about 8.5 degrees south, and it sits right around 5 hours and maybe 10 minutes, but you'd actually have to put a line up there to see it. But that's the location of Rigel, and you can assign the location of every star on here using declination, how far it is away from the celestial equator up and down, or how far it is from this 0 vernal equinox, moving either into positive numbers or actually moving into 23, which would be about right there, 23 hours. Okay, so this is one view. If I scroll down again, this is the second view, and this basically shows you where you left off. If you look at Virgo on this side, here's the ecliptic going back down to the winter solstice, and then heading back up to the vernal equinox, which is back up there again in March. But if you take a look at this side, and you see Virgo on this side, if you go back up to this one, and you scroll to the opposite side, you can see Virgo is on this side also. So what you're supposed to do is put those two together with the images that you see on the inside, and it'll actually give you sort of an idea of sitting in the middle on the Earth looking out toward the outside. If you take a look, same sort of thing up here. We have the hours, and there's 24, which is the same as 0. It goes down to 23 and 22, and again you can assign anything you want. There's Sagittarius, the teapot. There's Capricornus, the sea goat. There's Aquarius, the water carrier. Sitting over here is Libra, my constellation, which is Scorpius, and there's Virgo again, and there's the rest of Pisces, which was on the far side of the other, the last one we looked at. Okay, so we got alpha stars, We have beta stars, we have constellations, we have them so they actually set up a certain part of a map. So we actually have the, like I said, the crazy 88, and you can actually draw things all the way around here, and they're basically like states up in the celestial sphere, something that looks sort of like that. And again, that view I showed you here, they can be quite cool. I can go in and change these things too, but I want to actually get back to here. And then we move down to the last one, showing you from the south celestial sphere. Notice that there's nothing in the south celestial pole like there was in the north with Polaris. I'm not exactly sure how they navigate in the southern hemisphere, but I do know that they do use the Southern Cross, which you can see right here. And they use other constellations, but somehow they geometrically or geographically or whatever, they figure out where that is, so they know that they're actually heading south or opposite in any direction north, and then they can also figure out east and west from there. Okay, again, this is the CFA chart, and I think it's actually a really cool tool for astronomy. I'm going to be giving these to my kids tomorrow. I'm hoping they enjoy the activity we're going to be doing, but with that you can determine any place on the sky. You can also figure out if the sun is in a particular location, not on this map, because we're still not quite in March. If you actually go through and you see there's February, there's March 1, so tomorrow the sun would be right there. And then theoretically 12 hours, that's sitting right around 22:45. If you went 6 hours this way and 6 hours that way, you can determine what's got the daytime. These are all daytime constellations, or what is actually nighttime. Moving over, so you can determine what constellations can be seen at any particular time. If you actually want to see your constellation, like if I wanted to see Scorpius, I don't go out in November. I actually see it in the summertime, because the sun would be 3,000 years ago, or whenever the ancients set up the zodiac, the sun would actually be right here. Now my birthday is more like here. We're actually a little bit off because of the motions of the Earth around the sun and the sun around the Milky Way. These things do change with time. So we're about 3/4 of a constellation off. But basically the sun would have been here when I was born. Let's say right here when I was born. So this is not a good time to see my constellation. I really want to wait 6 months when this Earth has gone around to the opposite side. So now I'm looking at the same part of the sky I would have looked at toward the sun, except now it's in my nighttime sky. Beautiful constellation. Unfortunately, because it is so far away from that celestial equator, puts it really close to my horizon. I can basically see from outside of DC, I can see about 50 degrees down. So if I go to this map, you go to 50 degrees, I can see basically things that are up here. And if you take a look, and where the heck is Scorpius on here? Here's Scorpius, gets really close to that 50. These constellations I don't get to see. There are a lot of constellations in the south I would love to see, but I don't get that chance. Okay, well I hope you enjoyed this. I hope the CFA chart is something that you have of interest. Take a look at it. I have the website located up here. If you actually Google SFA Star Chart, you can actually see, listening to music when I'm not taping these things, you can actually see SFA Star Chart, and you can see lots of them. It is a PDF, so any of these would probably get you there. Here's an animation showing you the actual, and if I can move it more this way, I think you can see the whole thing. This is the animation where you can actually watch these things go this direction. So it's moving from east to west, which I know is backward than what you normally expect on a map, but again, you got to remember you're looking up and not down at a map, so things can be opposite left and right for west and east. But there is the ecliptic, there's the vernal equinox, there's the summer solstice, there's the autumnal equinox, there's the winter solstice, that's the path that the sun takes across the sky, there's the celestial equator, there's the north celestial pole, the south celestial pole, and there's the progression. Actually shows you the hours, as well as, doesn't really show you the degrees, but probably 10, 20, 30, 40, 50, 60, 70, 80, 90. Another view of the celestial sphere could be this one. Moving in a counterclockwise direction, moving from east this side to west on this side, and we're in the inside of this, not on the outside. Right now we're looking outside, but we'd have to look inside, so it actually is a different view. Okay, thank you very much, and hope you enjoyed it. Bye-bye.